Hi guys, so today we're going to start our trig unit and we're going to spend basically the rest of the school year working on trig. So to begin this unit, the first thing we're going to talk about is something called periodic data, and that's going to be our focus this week. So when I talk about periodic data, there are a few key terms that we need to know before we really get started. And those key terms are periodic function, cycle, and period. So let's go ahead and define those terms before we go any further. So a periodic function is simply a function that represents a pattern of y values. And y values are also called outputs. So when you have a periodic function, that means that you have this pattern of outputs, or y values, that are occurring at regular intervals. And we'll talk about what that means in just a little bit. So a periodic function is a function that repeats a pattern of y values, or outputs, at regular intervals. Then we also need to understand what a cycle is. So a cycle is just the fancy way that we refer to the pattern that keeps getting repeated within that periodic function. So a cycle is one complete pattern within the periodic function. And then another term we're going to talk a lot today especially is the term period. So a period is what we call the horizontal length of the periodic function. The horizontal length of the periodic function. And when I'm talking about the horizontal length, if you recall on a grid, an x and y axis, the horizontal length then would be the distance along your x-axis. So when I talk about a period, I'm really talking about the distance along the x-axis. So those are our three key terms that we need to keep in mind, not only for today, but throughout this unit. So a periodic function is a function that represents a pattern of y values or outputs at regular intervals. A cycle is a complete pattern within that periodic function. And then the period is the horizontal length of the periodic function, or the distance along the x-axis. So let's talk about what those terms really mean. So if you check out example 1, part A, we have a lovely little graph here. And this graph does represent a periodic function, and we're going to talk about how we know that in just a minute. But as you can see, this graph repeats the same pattern over and over and over again. And the way we can tell that that pattern is being repeated is by looking at a cycle. So you remember our key term cycle is one complete pattern within a periodic function. So when I identify a cycle, what I want to look at is the repetition of the y values. So if you look here, we have a y value of 2 at this point, and then we drop down to what looks like -1, and then we come back up to 2. And then here we start at 2, we go down to -1, we come back up to 2. We go down to -1 and we come back up to 2. So we can see that that pattern is repeating over and over again. And the cycle then is simply the piece of the pattern that started at 2 for the y value, goes down to 1, and then comes back up to -2. And we can see that pattern repeat itself over and over and over again. We can also identify a cycle starting at any y value that we want. So if I wanted to start at the y value of 0, I'm going to erase these markings real quick, and I'm going to use a highlighter. So if I wanted to start at the y value 0, I see that I started at 0, I come up to 2, down to -1, back up to 0. And this little chunk right here, we can actually see repeat itself over and over again in this periodic function. So I could start here and at 0 again. I can start at this 0 and at 0 again. Start at this 0 and at 0 again. So a cycle is really where we're talking about our y values and the repetition of those y values. So I started at 0 as my y value. I come back to 0 as a y value. And that in itself is one cycle within this periodic function. And it's repeating itself over and over and over again. So for a periodic function, it doesn't matter what y value we use. We can use any one we want. So if I wanted to start at a y value of 1, then let's see, that's not going to work. So if I start at a y value of 1, I actually have a y value of 1 here again, and then to here. Aha. So then that could be one cycle, and then I would use this cycle again from here to here. And that cycle is repeating itself over and over and over again. Okay. So now we need to identify what the period is of this periodic function. So what you want to do is you want to pick one cycle. So I'm picking the cycle. I'm going to start with this cycle here, where I start with a y value of 2, come down here, come back up to 2. So my period is the horizontal length of the periodic function. So what I need to look at are the x values of these points. So this point starts at the x value of 2, and this point starts at the x value of 6. So my period is the distance between those 2 points. So the distance means I'm going to subtract those 2 x values, and I end up with 4. Now let's make sure that our period is the same no matter which cycle we use. So for this cycle here, my x value is 5, 6, 7, 8. And my x value here is 12. So I'm going to take the distance, so 12 minus 8. The distance between those 2 points is 4. And notice that our period matches, which makes sense because we have shown already that this is in fact a periodic function. So the period of this periodic function is 4. And I don't know if you can hear that, but my puppy is being whiny in the background, so I'm going to go take care of her for a second. I'll be right back. All right, let's go ahead and apply this to a second example. So in example 1, part B, we see this little graph here, and we're going to see if this is in fact a periodic function. So what I want to look first are cycles that repeat itself. So a pattern that keeps repeating within this function. So I'm going to start with this point here where y is 0. And I notice that y goes up to 2, back down to 0, but from there it goes down to -2 and then comes up to 0. So this is one complete cycle. Let's see if it repeats that cycle. So I have y is 0, goes up to 2, back down to 0, then down to -2, and back up to 0. And it looks like we repeated that exact same pattern with those y values. So this is a cycle, and then this was also a cycle. So because those cycles keep repeating themselves, I know that this is in fact a periodic function. And I want to be able to identify the period. So what is that horizontal distance between each cycle? So what I'm going to look at are my x values of each of these cycles. So when I talk about a period, when I talk about distance, I always want to take the higher value first. So I'm talking about my x values. And those x values of these 2 points are -4 and 0. So when I find distance, I want to take the higher one first and then subtract the lower one. So 0 minus -4 is 4. And then let's make sure that that's the same just to double check our work for the second cycle here. So we started at 0 and then went to 4. So again, I have 0 and 4. I'm going to take 4 minus 0, which is 4. So the period of this function is 4. Go ahead and pause the video and work through part C. Figure out where some of the cycles might be, and then report back here to check the period as well. So when you're ready to check, let's go ahead and talk about a cycle. So when I talk about the cycles, I want to start and end with the same y value. So I'm going to have, I have a +1 down to -2, back up to +1. And it looks like that does repeat over and over and over again. So, and then here's another cycle. Then to find the period, I want to have the x values. So the x value here is, let's see, -1, -2, -3. And then here I have the x value of 0. So we're going to take 0 minus -3, which is 3. So the period of this function is 3. All right, so example 2. So with example 2, we're going to identify if the function is a periodic function, and if so, then we're going to identify the period of the function. So in example 2, part A, we have an example that's kind of tricky because it looks like within this function that we do have this cycle or this pattern that is kind of repeating itself. The problem is that the y values aren't repeating themselves. So for this first part, we have a y value of 2 and then, a y value of 3 going up to like, I don't know, 3.8, 3.7, and then back down to 2. But then here we start at 2 up to like, I don't know, 2.6, and then down to 1. So the y values within each of those patterns aren't repeating. Therefore, this is not a periodic function. So then looking over at part B, again, we're looking for a pattern that presents itself and keeps repeating. So for example, a cycle here, it looks like a cycle could be here. And then once again, it looks like it's going to repeat that same cycle. So is this a periodic function? Yes. And if so, what is the period? The period is, let's see, it goes from 0 all the way to 10. So we're going to have 10 minus 0, which is 10. Sorry. There we go. All right, and then I'm going to leave you free to do C and D on your own. Go ahead and press pause, work through these two problems, and then press play when you're ready to check your answers. So for part C, this is not a periodic function. So we don't have a period to answer or to find. For part D, this is a periodic function. And we know that because we see this cycle emerge and repeat itself over again. Okay. So if so, what's the period? The period is, let's see, we have x values of -3 all the way to 1. So 1 minus -3 is equal to 4. And we have a period of 4.